Hello, and thank you for joining me today for the latest Global Mapper webcast. Today we're going to be introducing the custom feature extraction capability in the LiDAR module. This is the sixth in the LiDAR processing series. Last time out, my colleague Katrina introduced the extraction capability that's been automated for recognizing things like buildings and vegetation. Today we're going to take a slightly different view of this extraction process by essentially manually identifying features within a point cloud. We've got a couple of different workflows we're going to go through, one to recognize a linear feature and the other to generate some three-dimensional polygons, ultimately generating a pitched roof. So the agenda today is fairly straightforward. The tool that we're going to employ to allow us to generate these three-dimensional features from our point cloud is the perpendicular profiling tool. We introduced the profiling tool in the context of LiDAR in one of our earlier sessions. With the LiDAR module activated, you can generate a cross-sectional view of your point cloud that will allow you to do things like editing and just simple visualization of a lateral perspective of your LiDAR data or your point cloud data. I'm going to revisit that tool today and expand on it by introducing this idea of perpendicular, or sometimes called cross-profiling. The specific applications that we're going to work on, as I mentioned, we're going to use some terrestrial LiDAR data, and it's very specifically that little screenshot you see on the left side is going to be a small section of that data we're going to use to delineate the edge of a curb. Now, obviously, we're talking about point cloud data that's at a very high resolution that would give us that ability. So this is data that was collected on the ground, and this little street scene that you're seeing here happens to be Hallowell, our home city here in Maine. And we're going to use a little small section of that to delineate, as I said, the edge of our curb. We're then going to use this same function, the same basic process, but we're going to generate a building model, a pitched roof building model. Essentially, we're going to create two separate 3D polygons representing the roof of a building. Again, in this case, it's using some airborne LiDAR. So we're going to begin by first introducing the profile tool in general. If you haven't followed any of our previous presentations, this is not a tool that's specifically generated or specifically designed for working with point cloud data. In fact, it's more typically used with terrain data. Right where my cursor is located in the toolbar, I select the tool, and it basically allows me to draw a cross-sectional view. This is going to be the basis of what we're going to be working on today. I can draw a single segment line, I can do a multi-segment line, I could even select a line that already exists, perhaps from a file I imported. You can select a line and generate a profile. If you want more detail on that type of application, look back at some of our previous terrain analysis webcasts or webinars and you'll get that information. Very quickly, when I draw my profile, left click, right click to draw that line segment, it gives me a cross-sectional view. Yours may not look exactly the same as mine. I've changed a couple of the settings, but particularly the background. That's something that can be changed under your display options. You can set your background color. Terrain color can also be set if you don't like that. Green color, you can change it if you want, and various other settings are available. So this is the basic function of the profile tool. Now I'm going to close the profile window and introduce you to the settings that are available for this tool. You could either access them from within that dialog box that I just closed, or with the tool activated you can right click on the map and it also provides access to the path profile settings. Now this function of this component of the software has expanded significantly within the last few releases. There's a lot of different settings that now can be applied. What I'm going to look at specifically today, and we're going to be using specifically today, is this perpendicular profiling function. The perpendicular profile tool is not enabled by default, but simply by coming into this dialog box, you can check the box next to display a series of profiles, which will significantly change the behavior of the profiling tool. Now, before we leave this box, there's a few very specific settings that I'm going to establish before we actually see this in its actual in an actual process. First thing is the adjacent button, which is to determine along a defined path that I will create when we go back onto the map view, how many perpendicular or cross profiles do we want? And there's a couple of ways that we can set this. We can establish a number of profiles. This will obviously be regardless of the length of the line. It would still give me the same number of perpendicular views, or I can specify a spacing value. So in this case, I'm going to set a spacing value of 10 meters between profiles. In other words, after I establish my baseline, I'm going to get a perpendicular view every 10 meters based on this setting. It also gives me the option of keeping the vertices that are already in a line that I would generate. In this case, I don't want that. I want to disable that option. I'm going to click OK. Now, the other setting that I need to establish now that we've established the spacing of my views, is how wide those views are going to be. In my scenario, I'm going to draw a line along the middle of this river channel right here with the intention of drawing a cross-section of the river valley at those 10-meter increments. So in order for me to see the full extent of the valley, I need to define the length of each of those profile lines. Right now it's set to 50 meters, which wouldn't give me a great deal of a view either side of the river. In fact, the river's probably narrower than 50 meters, so I'm going to have to expand this. I'm actually going to make this 2 kilometers in this case. So this is going to be a very wide swath that will be profiled along the edge of the river. Now, we're just quickly going over an overview of the perpendicular profile function. We will definitely be coming back into this dialog box when we actually look at this in the context of point cloud data in just a few minutes. But for now, just to demonstrate the functionality, I'll close the dialog box and I'll begin the process of drawing my profile line. And you'll notice I'm simply left clicking along that channel. You'll notice the buffer that's automatically created is a swath that's 2 kilometers wide. I'm just going to stop right here. I'm going to left click my final point, then right click to finish. Now, what you're seeing when we when we right click to initiate the display of the profile view, is the first cross section right here at the top of the river valley. That yellow line perpendicular to my path is now noted here as a cross sectional view. I can now navigate through each of those profile views, remembering that they're going to be 10 meters apart, by simply clicking the little arrow button that you see right here in the dialog box. So as you'll see, and noting on the map up just above where I'm sitting, you'll notice a line is moving. Each 10-meter increment is now being represented, and you can get an almost animated representation of the changes in the river valley as we move downstream. Now, each time, as you can see, I'm simply clicking on this arrow. You can, and unfortunately you will not see this, you can also use the arrow key on your keyboard, which is what I'm doing right now, to do the same thing. In fact, there's also an option to hold that arrow key down, and it actually does allow you to more specifically animate. I'm not sure if this is coming through in the recording, but it almost displays an animated view by simply holding that button down on my keyboard. So this is just one example of the use of the profiling tool in its perpendicular form. Obviously not relevant to what the broad theme of our current presentation is, which is working with point cloud data, but by way of introduction, it shows you what the tool allows you to do. So in order to show the perpendicular profiling function in the context of point cloud data, I've loaded, as I said, a small section of the terrestrial data that we saw very quickly in our introductory slide. This is a very small section of the street, and you can see on my multi-view interface here, we've got a top-down 2D view. We've got a 3-dimensional perspective where you can see some of the characteristics of the point cloud. You can see some traffic cones in here. I think they actually stopped people parking on the day that they were actually collecting the data. That's why the traffic cones are there on the street. And you can see some signage and a little bit of the building. Now, these are quite significant features, as you will see when we get into the workflow and how we address this idea of delineating the edge of our curb, because those features may come into play. Also on the multi-view interface, we have a profile window, which you'll notice is empty right now, as it says no profile is available. My intention, as I said before, is to delineate the edge of just one small section of this curb. If I wanted to do that in a simple 2-dimensional form, I could simply use my digitizer and very quickly trace this point cloud top down. That would give me a 2D line feature. Not very useful, to be honest. So what we're going to do instead is digitize the edge of that curb as a 3D feature, and we're going to use our perpendicular profile for that purpose. Now, as before, my first process is to generate a profile. I'm going to generate a series, again, of cross-sectional profiles. Activating the tool, we want to go back into the dialog box. That's fine. I'll try that one more time. Back into the dialog box where we were a few minutes ago. And we need to change some of the settings in here. We are going to continue with our perpendicular profile, but obviously in this case we do not want a 2-kilometer wide swath. That would be way beyond the requirements for this process. Nor is our perpendicular sample spacing going to be applicable. It was 10 meters previously. I'm going to change this value first. Now again, knowing what the perpendicular profile tool does, what we're doing in this case is generating a series of cross-sectional views perpendicular to the curb itself. We will trace the curb as the basis of our path, but the profile views will be perpendicular to that curb. So the length of each of those profile views will be less than a meter. I'm actually going to restrict that to about 3/4 of a meter. 0.75 meters in this case. So we're going to get a small little section of point cloud data within each view. The perpendicular spacing, once again, we can define based on a total number of samples or on a fixed distance. And in this case, once again, I'm going to define this. I'm going to put a meter in. So we'll get a different view every meter as we go along that curve. There's no right or wrong here as far as these values are concerned. The closer the spacing of your perpendicular views, the more vertices you're going to be adding to the resulting line feature. Mine's are going to be a fairly low resolution line. 1 meter between vertices is okay in this situation. If you're doing some fine digitizing, remembering that this value essentially represents the vertex spacing. So that's what we're defining here. We'll click OK on that setting. Now, unlike the last example where we profiled some terrain data, this time we're profiling a point cloud. Now, if you recall back to that presentation where we introduced the idea of generating a cross-sectional view of our point cloud data, drawing a line through some points is not going to give you any display within that lateral view. What we need to do is expand that view. So we need to essentially assign a swath or a buffer area around each profile. And we do that right here at the bottom of this dialog box. The LiDAR display options gives us two choices. One, if we're just doing a normal profile, as we did in one of our earlier presentations, it's not relevant in this case. Now what we're doing is defining the width based on our perpendicular profiles. So if you recall, when we were developing the extent and distance between each profile, we defined that as a meter. If we leave this at 0.5 meter, it'll mean that we will get a 0.5 meter swath at each 1 meter distance. And I think that will work in this case. Again, we may lose a little bit of our data, we may lose a little bit of the resolution, but that's fine for this example. So 0.5 will work in this case. And once again, we will see in a few minutes where this value comes to play and what it results in when we actually generate our profile view. So once again, the three key settings here are the perpendicular spacing, the perpendicular path length, in other words, that's the lateral length of each profile, and then the width of the points that are going to be displayed within each profile view. We'll click OK. And once again, we're going to define the path itself. This is just going to be a simple line that I generate along the edge of my curb. It doesn't need to be accurate, it doesn't need to follow it exactly. As long as the curb edge falls within the extent of that green buffer area, we should be all set. Your choice on whether you want to expand this length, give yourself more points to work with, especially if the thing that the object you're digitizing is maybe not a regular curve but it deviates. You might want to expand that width just a little bit. In our case, this works fine. I right click to finish my profile view, and we will ultimately see that now in the window at the bottom of my screen. I'm just going to pull it up a little bit here, and we can now see a cross-sectional view looking through 0.5 meter, 50 centimeters of points, and we can see very clearly the structure of our curve here. And basically what we want to delineate in this exercise is this transition, this break line, if you like, between the horizontal and the vertical parts of our curve. Once again, as I demonstrated previously, I can use my arrow keys to navigate along the edge of the curve. Now, you'll have noticed there's a couple of these profile views are a little unusual. They're essentially compressed, and the reason for that is, as I pointed out in the introduction, there are other objects here along the edge of the curb. I think this is parking, 2-hour parking sign right here. You can see it in my 3D view. Well, that's what we're seeing in profile form right now. And those of you who are familiar with the profile tool in Global Mapper will know that the vertical extent of what's being profiled will be based on the extent of the available z-values within the data. And in this case, I have some larger z-values, so I have had to extend, the profile view has extended. Now, the solution for that is to clamp the data to a specific elevation range, which I'm going to do in just a few minutes. But let's continue our journey along the curve here. Once again, we've got a couple of anomalies here. I'm not exactly sure what some of these points represent, but they're obviously in the point cloud. You can also see these in the 3D view as well. They're distorting this view. So very difficult to envisage digitizing from this perspective. We're not getting the detail we want. But noting on my 2D map the little line moving steadily along the curb, which is going to be the basis for my digitizing exercise. Now, looking at this view, this looks like a fairly reasonable perspective on my curb. I'm noting the elevation range within this view. I'm going from 7.7 meters to 7.9 meters. I may jump that up to 8 meters just to be sure. What I'm going to do next is change one of the settings so that every profile window, every profile view is limited by that extent, 7.7 to 8.0. Once again, back in the settings area, what I'm going to do now is clamp the top elevation and clamp the bottom elevation. Top elevation, again, rounding it up, I'll make that 8. Bottom elevation, we'll make that 7. You'll notice these values are already populated based on the extent of the current profile view. Just make it a nice round 7.7 in this case. And we'll click OK. It will slightly change the perspective of the current profile view, as you'll see. It condensed it just a little bit, but again, I've defined very precisely now what my range is, and that will be consistent throughout the extent of each of the profiles, giving me a much more consistent basis for my digitizing exercise. Because it's a little lower than I would have expected, but that should be okay. I'm back to the start now, and my objective now is to digitize, and in order to do that, I'm going to initiate the tool, the new tool that we've introduced for extracting lines. You'll see the button right here in the toolbar where my cursor is located. Extract lines from perpendicular profiles. When we click the button, brings up a dialog box that allows us the option to choose between lines or polygons. Choosing the Add button, we choose either a new line feature or an area feature. In this example, we're going to begin with the simple one. We're going to begin with a line, and we can, if necessary, define the feature type. This is carried over from our digitizing function. We are essentially digitizing now. We're digitizing in 3D, but you can see we have options here for determining what that feature type is. I'm going to leave this as an unknown line type in this case, but if you had a feature type that was a curb, for instance, or something that represents, maybe it's a fence line or something of that type, you can obviously assign that feature type. Everything else here should be fine. We click OK. And I move my cursor down, and you'll notice I have this different cursor now, this dot now attached to the end of my cursor. What I'm going to do is I'm going to pick up the vertex, which is pre-added here as a center point, and I'm going to add it right at the corner. You'll notice now I have placed that vertex right at the corner. I can move it around if necessary. It's completely editable, but I'm going to begin the process by defining the edge within my first profile view. This dot, by the way, this yellow dot represents the center point. And you can see I was relatively close when I generated that line. Not exact, but that's fine. It doesn't really matter in this context. Now, as again, I've defined the vertex in a three-dimensional space for the first section of my curb. Using the arrow buttons, and I can do this in a number of ways. Again, the arrows on my keyboard, the arrow buttons right here in the dialog box, or we now have a slider bar in the dialog box that appeared. I can scroll along, and I'm actually going to go all the way to the end of my profile view. And you'll notice that in the context of the profile window, the location of this dot has stayed in the same place, but the actual curve obviously has moved. So my line was obviously not a consistent line, which again is perfectly fine. What I can do now is move this, pick it up and drag it, again, so it coincides with the edge of the curb. If that's all that I did, I would generate a line from the XYZ location of my first profile to the XYZ location of my final profile, and every vertex between all of those vertex 1 meter spaced vertices would be interpolated. And you'll see that as we scroll back through. You'll notice that dot will incrementally move. So by the time I make it back to the first perpendicular view, it's back down where it was. So that's a very rough digitizing. If I simply exported or extracted this feature now, I would just get a single straight line, not adhering precisely to the curve. What I'm going to do, based on the available time, I'm not going to do every profile view, but I'm going to scroll through a few here and show how we can now fine-tune the position by simply dragging that green dot. As we scroll through each of these individual views, we can accommodate any deviations in this curve, and each time I move that green dot, what I'm doing is essentially replacing one of the 3D vertices, in this case moving up just a little bit. And you can see now the importance of that 1 meter value that I placed before, because if I had made that 50 centimeters or 25 centimeters or less, I could very finely tune the vertices in this feature, very precisely tracing the edge of the curve. And again, with all due apologies, I'm not going to stop at every view right here. There's a little bit of an anomaly in my data here. I think this some other features on the edge of the curve. The solution for this may be to constrain the view of the points a little bit less, so you're not getting a lot of noise in there. Maybe limiting it to 20 centimeters, maybe 25 centimeters. It gives you the option to have a finer perhaps a finer resolution. Let me just jump to the next one, and we can again fine tune our point right here. It looks like it dips a little bit at this case in this location, and it's close enough for the rest of the way. And you can see that dot now moving around as I scroll through each section of my curve. Again, taking the time to do this based on your individual settings will give you a higher precision or higher resolution line feature. When you're done fine-tuning those vertices, last step in the process is an extraction process. What we've done up to this point is obviously simple digitizing, or vertex placement, I should say. Now we're going to convert those vertices into a single line feature. Clicking the extract button, this dialog box should look familiar to everyone who uses Global Mapper. This is our standard modify feature info. If you were doing any digitizing, you would see this. You would typically select a layer, and a feature type once again can be chosen. I'm leave the defaults, click OK, and we now have a three-dimensional line. Easiest way to visualize this is to turn off my point cloud, and you'll see that line. Don't worry about the profile view still represented here, but you'll see that line feature now represented in my 3D view. And if I look along that line, it's hard to see at this scale. Zooming a little closer might be easier. You can see it does change direction to reflect the edge of the curve. So this three-dimensional line is now accurate, both top-down and in a vertical axis as well. So in this next scenario, we're going to use the same basic procedure that we followed for our curve extraction, but in this case we're actually going to extract a building, and the building is going to be comprised of two separate polygons. This building in question, by the way, you may recognize. We've used it for some of our other workflows or other presentations. In fact, I believe Katrina used this example in our last LiDAR webcast to demonstrate the capability of initially automatically identifying building points within a point cloud and then extracting those as a three-dimensional feature. One of the limitations of that automatic extraction process is that it assumes that the building is a flat surface, a flat roof. And if you move over here to the right side, you'll notice in this case there is a fairly distinct pitch to this roof. So the workflow that we're about to follow will actually allow us to generate a model that accommodates that pitch, that actually will allow us to capture that pitch. And it does so by capturing two separate roof sections and having them abut together. So the procedure is the same in that we're going to use our perpendicular profile tool. We're going to add vertices in each of the perpendicular profile displays, but in this case it's actually going to be two vertices per display, where we're going to define the front edge of a polygon And as we scroll through each of the perpendicular profiles, we will have the opportunity to fine-tune those. In actual case, in this situation, there's really no need to fine-tune the vertices like we did with the curve, because the building tends to be uniform. Once you've established the beginning points and the end points, what happens in between is a fairly straight line, so we don't need to adjust those vertices. So before we embark in this process, we need to do what we did last time, which is change some of the settings for our profile. Again, profile tool has been selected. We go to the settings dialog box, and where previously we established a perpendicular path length of about 3/4 of a meter, this time, because we're going to be extending the profile view over the full range of the full width of the building, we need to expand this. In fact, we're going to bump it up to 100 meters. That will allow us a profile view which will extend either side of the building roof. We're going to have a little bit more area than we need, but that's fine. Our perpendicular spacing, we're going to leave that at 1 meter. In other words, as we scroll through this building, we'll have vertices placed at 1 meter intervals. We can leave that as is. Also, we need to define the number of points, or the width of points, that are going to be visible within each profile view. In our curb scenario, we limited that to 0.5 meter. We're going to bump this up this time because this is a relatively low density point cloud. This is an airborne collected LiDAR point cloud. We need a few more points, so we're actually going to expand this to 3 meters. Now, with this value at 3 meters and with our perpendicular spacing set to 1 meter, the consequence will be that there will be overlap. Within each sequential perpendicular view, there will be points that appeared in the previous view and points that will appear in the next view, which is fine. That's not a problem in this scenario. It's okay to have that overlap. Now, the final setting that we need to establish, as we did with our curb scenario, is a top and bottom elevation range. We happen to know that in this case, the top elevation is going to be 32 meters and the bottom elevation is 27. In other words, our profile views are going to consistently be limited to that 5 meter range. If we didn't establish that constraint, we would get the full range of points, and being able to distinguish the different sections of the roof, as you will see, would be much more difficult. So with those settings established, we simply click OK, and we then use our profile tool to draw our profile line. Once again, doesn't need to be precise. As long as we're following approximately the center of the building, making sure that the entire roof area is enclosed within the swath that we've defined. It's a left click and a right click. And immediately we will see the first profile view displayed in the profile window at the bottom of my screen. That represents this line, this first perpendicular line. Now, because we have limited the extent, the vertical extent, from 27 meters to 32 meters, we're not actually seeing that many points. We're not seeing any ground points in here. There's perhaps a few vegetation points that are visible, but certainly we're not seeing the building yet, because this is beyond the extent of our building. Using my arrow keys, as you'll see, that line is now moving towards the edge of the building. We're seeing a few more trees in here. And if we get right to the point where the edge of the building appears, we will start to see that roof line. And you can see quite clearly, once again, the pitch of that roof line is visible within the profile view. Our objective, as I said before, is to create a polygon representing each side, or 2 separate polygons representing each side of this roof. And we're going to do that again by adding vertices that define each of the edges of the polygon. So the procedure is the same as before. And let me back up just a little to make sure we actually have, maybe we could start our building right about here. I think this probably is the edge of the building, so we can confidently place our end points here. Procedure is the same as before. I use the extract option. Perpendicular profile extraction. I use the add option as before, and where previously we selected line, this time we're going to choose our area feature. And you'll notice my feature type is already pre-selected as a building roof. This is because I had performed this scenario previously. It remembered this setting. Our profile dot color, because we're actually going to be generating 2 different features within this profile view, unlike the previous scenario was a single line, the dot color will be important. Now, it does give us a different dot color automatically. I think the first one will be green, the second one will be red, but if you need to define that manually, you can. And certainly if you're creating multiple features within one profile view, you'll want to make sure you're differentiating what each feature is consistent, the line that represents each feature, and so you'll want it to make sure those dot colors are distinct. In our case, we're okay. We simply click the OK button, move our cursor down into the map view, and we can precisely define initially the apex or the high point of the roof. Let me just actually go forward one. I think this is probably the best one to start on here. And you can see quite clearly here where that roof line starts. I'm going to click once with my left mouse button. And in our previous scenario, that would be all that we would have to do with our line. But now, because we're generating a polygon, we're now given the option of placing the second vertex, essentially defining the front edge of the polygon. So this is a left click and then a right click, just like it would be if we were digitizing in a normal 2D environment. Left click, right click will define that line segment for us, and you'll see quite clearly now that line has been defined. Now, before we leave this view, I'm going to go back up to the perpendicular profile extraction dialog box and click the add button again, because we're going to add the second of our two features, the other section of our roofline, if you like. The dot color, as I mentioned, will automatically be changed. It will be a red color, so I don't have to change anything here. Click OK. And one of the really nice things about this tool, if there is an existing feature that has been created, it will snap. You'll see it jumps right in there and snaps to that existing feature. So I don't have to precisely place it now. It is automatically matched to the position of the first polygon that I created. Left click once again and move my cursor down to the edge of the roof once again, and right click to place that second vertex. You'll notice that these 2 points are highlighted. If I wanted to, I could pick that line up and drag it, or if I simply select one of the points, I can move that point around if necessary. I can fine tune it. Now, as before, we're going to use this slider bar to scroll through the building. You'll notice this line moving incrementally along the ridge of the building, and you'll see the corresponding points being represented in my profile view. And we will get to a point where we reach the edge of the building, the other end of the building, I should say, and eventually those points will disappear. We're off the edge of the building once again. So moving back slightly, you can see now this represents the edge of the building. If I needed to, I could fine-tune the position of these vertices. I'm going to grab this right side vertex and move it slightly out to the right. Maybe the same with the left edge vertex. Again, move it out. I could move the building apex again. Because these are snap points, I would have to snap them again. One point would move independently, so moving the other would snap it back into place. I think that's okay for now. We'll just leave that middle point as it is. And as I said previously, we would have the option to fine-tune the positioning of these points if necessary, but because this building is a uniform structure, in this case we're not going to do this. We've defined, as you can see visually, the plane of each of these roof sections, and we're ready to extract these to vector features. Before we do, there's one more thing that we need to establish. If we simply hit the extract button at this stage, the full extent of the profile view would be extracted as a vector feature. Now, we wouldn't want that, because obviously this profile goes beyond the extent of our building. As you can see right now, the building does not exist here, so we would get more physical area than we need. So what we need to do is to define a profile view that represents the edge of the feature. And again, I'm moving this slowly forward, and there we can see that's where the point at which these building points appear. I'm going to select one of the sections. I've highlighted this point. I'm going to right click. I'm going to go to my perpendicular profile options, and I'm going to set the start, make this profile view the start of the extracted feature. So choosing that option, go to the other side and do the same. Because there are two features, we basically need to define this twice. Right click again, and once again, this is the start of that feature. So all of the points that precede, all of the vertices that precede the selected profile will be ignored when we extract this vector feature. Obviously, to complete this, we need to go to the other extent, the other end of the building, and again, we'll get to the point where those points disappear right about here. And once again, with this point still selected, I'll right click, and this time we're going to choose the stop option, and we'll repeat that once again for the other side. This is the point at which we will stop the extraction process. So with those parameters established, essentially what we've created are two bookends for this building. The only areas that will be extracted are between these vertices, in other words, to the extent of the edge of the roof, but only from one edge of the building to the other. A single extract process now will extract both features at once. They'll basically be two separate features. And the feature type has been inherited from what was selected before. It's still building roof. I could assign this to a specific layer if I had one available. Right now it's user created features. I'll just leave that as a default. This dialog box, once again, is the same dialog box you'll encounter when you're digitizing in a 2D environment in the application. We'll click OK with these settings. And first thing to notice is we have a new layer in the Overlay Control Center. It's my user created features layer, and it has two features, two roof sections if you like. I'm going to close this dialog box. I'm going to turn off my point cloud, turn on, I have an underlying ortho as well as some underlying DTM data. I'll move my cursor over and you will now see in my 3D view this building now represented as a more precise three-dimensional model. It's actually two separate models, but you'll notice that allows us to more precisely represent the pitch of that roof. So our 3D digitizing tool used very creatively in this case to generate a three-dimensional building model. So today we covered a number of variations kind of around the theme of using the perpendicular profile tool with a point cloud and using the LiDAR module, allowing us to do some 3D digitizing or extraction. We extracted our curb. We used the same tool very creatively to create our 3D building. I should have mentioned during those workflows, those are now vector features, can be exported in any of the supported vector formats, CAD file formats, shapefile if that's what you want as well. So thanks for joining me today. If you have any questions about the content of today's presentation, or indeed any of our LiDAR processing presentations, or any of the previous webinar content, feel free to contact our technical support team, geohelp@bluemarblegeo.com. You'll find them there. Sales questions, if you're not a current user and you're interested in a quote perhaps for your company, the folks in our sales department will answer your emails. Orders@bluemarblegeo.com is how to get in touch with them. And finally, for those of you who are not currently using Global Mapper, I do encourage you to download a trial. You can get an evaluation copy, try it out for a couple of weeks. You can evaluate the software. You can also activate the LiDAR module itself and try any of the workflows that we're going through in this LiDAR Processing Works series. Next time around, we're going to take a look at transitioning from a point cloud into a surface model, DTM, DSM, all of those types of raster surface models. So that'll be next time. Look forward to speaking with you then.